Your first quiz is available. You have until next week to complete it. It should take you about 30 minutes or so to do, maybe less. You have to work on it by yourself, but you can use any other resources besides people. If you have questions or if you notice that anything's wrong, stop by office hours and let me know. You can also submit your current homework assignment late until Monday, no penalties. So if you need the weekend to complete it, use it. Make sure that you get it in. Other thing is that there's quite a few people still making the exact same mistakes that I pointed out with random the other day. If you're still having issues with the randomness, look at the post that's on CampusWire. Look at the examples that are there, and please follow along with the correct version so that you do it correctly. So just in terms of questions, how many random number generators should you create? One, right? Where should you probably create that random number generator at? In main, right? How many times should you seed it? Once. Functions should accept a reference to the generator if they need to use it, right? If you follow those rules, you'll be perfectly fine, right? And every time you need a new random number from the random number generator, right, request it by using like gen or distribution gen, and you should get that new value out. If you're creating your random number generator inside of a function, right, it's possible that you're recreating it every single time. If you're putting your random number generator inside of a loop, you're definitely recreating it every single time that you go through, right? So watch out for those mistakes. Apparently, they're very easy to make, but if you look at the examples, you shouldn't be making them. We're going to get back into lecture. How many of you guys have used Git before? So we'll start integrating Git into our assignments just to show you that how it's being used. So Git is a version control manager. Have you guys ever had multiple versions of the same project? Right? You have like version 1, version 2, version 3, maybe scattered 4, scattered across a whole bunch of different folders, or maybe different file names because you want to try out something different. Right? It can be really hard and complicated to manage all that, and Git is designed to exactly tackle those problems. There is built-in Git integration into your CLion. So if you want to enable that, you go to version control, and then you go to enable version control integration, then you select Git. And this will create a new Git repository for your project. One of the files that you're going to want to create is called gitignore, and its name is .gitignore. And inside this file, you specify things that you don't want Git to track. By default, Git's going to track everything you tell it to, but if there's things inside this project that you don't want to track, and your Git will tell you about those, that like, oh, these versions aren't being tracked. Sometimes there are certain files that you just don't want tracked. A lot of times those will be like executables or things that aren't really like directly like related to your particular project. So things that we're going to ignore are cmake -build -debug / to let it know it's the file. So ignore everything inside this directory and below. This is just where all the build stuff occurs at. And there's also another hidden file called .idea, and we're going to ignore that file as well. These guys you can see are now all red, but if we want to add them, we also want to, for me, I need to also ignore the desktop.ini. The ones that are red aren't a part of your Git repository yet. They're not being tracked. So we're going to highlight all of them, minus this .desktop.ini. Right-click, go to Git, go to Add. And now these files are all being tracked by Git. So Git will be tracking them, but Git will only save the state of those files when you tell it to, which you can do by pressing Control-K to make a commit. So over here, it's going to list all the files that it's going to add to this commit. You can think of a commit as like a snapshot of your project at the moment. Or if any of you guys like play video games, it's a save file, right? It's showing what your game was like, what your project was like at this exact moment. So I'm going to call this one like our initial commit. And I don't want to do any of these things. And then press commit. And now Git has this version of my files as they are right now. I recommend to commit early and to commit often because the finer your commit, or the closer together your commits are, the easier it is to roll back a particular change. Yeah.
Automatically, or is there...
No, just when you do like version control git commit, which maybe is not being shown over here for some reason. Oh, commit's right up here. It's going to take it's going to save your program or save your program as it is right now, right? So think about it. There's only manual saves, right? There's no automatic saves. So generally, like every time you complete a feature and you finish doing something, you're probably going to want to add another commit in there, just so that you're able to get back to it. If you want to try something different, a little bit experimental, what you can do is you can go to git version control, git branches, and you can create a new branch, and you can try out all the different stuff over in that branch, and then if it works, we can merge it back in later to make those commits a part of our main project. But it lets you try out things that you're not sure if they're going to work out correctly very easily. But we'll show that a little bit later on. So last time we left off, we still needed to be able to display our board. So how should we go about doing this? Right, we want to show the contents of our board to the screen. Not supposed to be complicated. Right, we have a vector of strings. How can we go print them out to the screen? Just have like a for loop, like for, right, const auto reference row in board state, right? std : cout row, maybe. And then we need to include iostream because we're planning on using it here. Right, so something short, sweet, simple. And if we want to make it look better later on because we find that it doesn't look nice enough for what our purposes are, we can go and update that later on. So at this point in time, we pop back to Tic Tac Toe. Notice we have this complaint about board. Board is not a direct. Oh, should be little board over here. Board size, and what character do you want to use as a blank character? Just say it's an asterisk or something to make it show up there. So great, we're initialized. We might need some other things. So we have our board, and we now might want to try making our board to see if it works and is displaying correctly. So we'll just comment all this stuff out for right now. I'll pop over here into main. Yes, we will want to do this eventually. But we can like say pound include board. And then we might say like I want a Tic Tac Toe game : board because it's in that namespace called B. Maybe it's a 5 by something, and we're using pluses for the blank spaces. And then we can say b.display, and it should show up on our screen. So do test early, test often to make sure that things are working. We have a complaint over here that we're calling determine starting player. So back here in tic-tac-toe.cpp, we haven't actually implemented that function yet, so it's complaining. Back in. Seems to have compiled. And ta-da, some stuff got printed to the screen. Very fancy. But we still have a bit more to do. So maybe for determine starting player, we might need a new variable. Maybe it's called int player turn. Maybe by default up here, we do want to make sure that we initialize player turn with something. And if we're planning on setting it to something else that makes sense later on, we might want to give it like a nonsensical value right now, like -1. And for right now, here we might just say something like player turn is equal to 0, right? It's the first player in the array. Yeah. just because I knew I was going to call determine starting player later on. So I put it to some like nonsensical value so that if things went wrong and it didn't end up getting initialized, I would be like, oh, it's -1. I set it to that funny value. So it must have mean I forgot to initialize it. So which function would you guys like to do next? You want to do get valid move? Sure. So we need a new class called move. We do want to add these to our repository. And then this guy might now also be in the namespace Tic Tac Toe game. Should getting the valid move change our state at all? Probably not. So we'll throw in const here. So this guy's complaining because I didn't put the const there. Sometimes it happens if you do the alt enter too quickly. So question for you guys is, how do we end up getting a valid move from the user? What should this look like? Again, think very high level. What do we want to do? So you might ask them to enter a move, right? How do we want our user to enter the move? Right, they might give like a row index, column index, right? So you might say enter something like, 03 or 02 or 11 for what they want to play, which means later on we might want to update our display to put the indices on there. So they enter a row column index, right? So we prompt them for that. We read it in, and then check to see if it's good, right? We want to keep doing that until, well, we don't want to keep asking them for a move until the game is over, right? We want to keep asking them for a move until they give us a good move, right? So you might have something like a move, player move. Oops, that should be in question marks. So we might say something like do. We need to include IO stream here. And we're also going to need this hint. So we ask them to enter in their move. Down there. So then we might do something like std : get line, and we want to get a line into so we read in the entire line, right? Then we do a string stream, string stream, and we call it in user in, and we pass in line, right? And we want to keep doing this, while the move is not valid, right? So depending on how you do this, it might be something like while not player move dot is valid. That makes sense, right? And then so we might now need one other thing like player move dot parse we might say something like player move dot parse input user in. Like we might have the move parse the input for us. Are there any questions here?
Have you gone over parse?
I just made it up. Right, this parse input is just a brand new function that we just said that we needed right now because we need to get that line right and we need to like parse the input, which we can do very similarly to how I showed you guys in class earlier to see if it's valid or not. So I'll show you guys how to do that in 1 minute over here in parse input. But are there any other questions? Yeah. The entire line is inside the string stream, and that's its current content. So when we go to read it out in 1 second, we'll be able to read hopefully the first number followed by the second number. Yeah, the A space B space C, yes, would be inside the string stream. Yeah.
How does that?
Well, we're assuming we parse the input here on line 44, and that's not going to like update the player move. Would be the assumption.
The function is.
Yeah, it'll be set here in line 44. Yeah, and then in this function parse input. Any other questions? So we've now come up with two other functions that we need. We need to figure out if the move is valid, and we also need to be able to parse the input. Right? So more problems within inside of our problems. So the first thing that we have to do now is probably go over to move if we want to finish doing this. And we are going to need a public and a private section. Yeah.
Let's say
Okay, so you want to do the is valid move to take the input.
I'm saying I would make that.
Well, yeah, but you have to get the input set ahead of time, right? So I mean, like, it depends on how you want things to be structured, and you're more than welcome to do things a little bit differently. But then you might need to say like, okay, the input is valid, then set the input. But if we've walked through the input a little bit, it's not going to be structured. It won't be there anymore because we'll have modified the string stream. So do you want to change it? Change it. Here, we're going to leave it alone. What members do you think that game would have? Not the move, the game. The move would have. What things do you need to know? We need to know like what row you played on, as well as what column. Anything else? Do it again. Yeah, we're going to need to apply the move eventually later on. But for right now, anything else that you can think of in terms of members, not methods? We will need to figure out, like bool parsed successfully or something. We might also want to keep track of like which player made this move, right? So if we want to keep track of which player made this move, what do we need? Will we just have another player? Or something else? Maybe a player reference, right? Because we don't want to copy the entire player over. You probably want to be able to refer to them. So we might have a player reference, and so up here we're now going to need to include player.h. And we might call this one like the move maker, like whoever made this move. Maybe you want to just call it like maker. These things seem good for right now. So one of these things, because we have a reference, we probably, this thing always needs to be initialized, so we can't have a default constructor anymore. So we have to have a move that takes in, I guess it's valid for the move to modify things, right? Move to modify the player, or even players. Or maybe not. Ours probably doesn't need to modify the player at all, so we'll take in a const player reference. This one's pretty simple. We just make maker here. Right, that's done. And then we said that one of the methods that we now needed was to parse the input. And then this guy, we need to pass in whoever the current player is. So back here, we might need to, in Tic Tac Toe, be able to get who the current player is right now. But we'll be there in a minute. We wanted parse input, right? And also notice that all my includes are outside the namespace. Otherwise, it would like nest the namespace again. You'd have like tic-tac-toe game, colon, colon, tic-tac-toe game, colon, colon, like player if I put player inside here. Or for the string stream, it would now be like tic-tac-toe, colon, colon, std, colon, colon, string stream to be able to reference it because it was now inside the namespace. So I need an std, colon, colon, ss, a string stream reference called input. Okay, so the first thing that we should try to do is read out our two values, right? So we should probably try to do something like input arrow arrow row arrow arrow call, right? And then we can do something like if not input parse successfully equals false, return. That would mean we didn't read we didn't read either the row or read the column. Does that make sense? Yeah. But so the input being valid just means I was able, so the input would cease to be valid if I failed to read from it, right? We know that the input's going to be good beforehand because something was passed into this string stream. So it will be valid to read from. But you know, if you wanted to be like extra safe, you could, I guess, throw this line of code up here as well. And it's now extra safe, but you still need it to work. Any other questions? Then the next thing that we need to do is we need to check to see that there's nothing left. right? That we weren't able to read anything, that there's nothing but white space left. So a really easy way to do this one with string, and maybe I might be able to clean this up a little bit. Left first. Or maybe this could probably even be written a little bit easier as if input So now what I want to try to do is I want to try to read the rest to see if there's anything left. So I can just do input arrow arrow leftovers. And this will attempt to read anything that happens to be left, right? Do we want this read to succeed or to fail? Do we want anything to be left after we read the row in the column? No. So do we want this read to succeed or do we want it to fail? Fail, right? So we might probably actually need to move this guy down a little bit lower. Actually, what we can do is get rid of this. So we set parsed input to be equal to be whether it's true or not. Then over here, after we read this in, we can do the exact same thing. And we'll now say it's equal to So you might be like, what does this even mean? So let's say that we try to read the input, right? And this returns true, right? That means that it's good to read from. So if it's good, right? Well, true, and if we read the rest, that's good. True and true will be true, right? But if this guy was bad, parse successfully would be false, so it would stay as being false. Or if the first one was good and the second one was bad, it would also end up being as true and false, which would be false, right? And then finally, we can do this, parse successfully equals parse successfully. And again, we didn't want to read anything, not input. And then we could probably even get rid of this. And now it might be a whole lot less clear, but it's a lot less code. So questions here, because I know this is a bit complicated. Yeah. Yes. If you read from it, its state will change. Depends on whether the read was successful or not. So yeah, so like if the read was successful, its state will stay as being good. If the read was unsuccessful, its state will turn to being bad. There's another question behind you? Yeah. So it'll be true if the input is good, right? So this line right saying right here is input must start out as being good, right? This next line of code says we must have read both row and col, right? This final line over here is saying, and we weren't able to read anything after the row and call. Yeah. So if since we haven't read from it, it should still be readable, which should be good. So like if the user didn't type anything at all, but if they don't type anything and don't press enter, we don't actually get to this point, right? Because the user has to type something. If all they entered was just enter, then what we get back would be like the empty string. And then we'd attempt to read, so the input would be good because we haven't read anything out of it. Then we'd attempt to read row and column, which would fail. And so the input would become bad. And so we wouldn't, we'd set the parse successfully to be false. Yes? Well, we haven't checked to see if that they're both in bounds. There's some other things that we have to check on later, but this means we're just able to parse them successfully, right? We have that other function, is the input valid, to determine are these things like in bounds and whatnot. Because if the user plays at -5, -30, right, you want to be like, no, you can't really do that. Or yeah, but if the user plays anything besides 2 numbers, this will fail. So right now, this is just checking like the format that is syntactically valid, right? But we haven't checked to see whether it's semantically valid. The inputs actually make sense. So this is guaranteeing that we always get 2 numbers, 2 integer numbers separated by at least 1 white space character, and nothing else, right? They're not. This function is not guaranteeing that those numbers are like in bounds into our Tic Tac Toe board. Yeah. Yeah, it'll attempt to parse the input as an integer. But if it fails to actually read it, like the user enters in Bob, will fail to read a value. And then so the input would become bad. And then parse successfully would end up being false at the end. We might also, over here, we set our maker, but we probably want to set like row, column, and parse successfully to something that makes sense before we use them. So we might have something like row is -1, like -99. Call is -98. And parse successfully is false. Right? Because we do want to make sure all of our members are initialized. Because if we don't specify them to be initialized to be something, for the basic types like int, their values are undefined. They're undefined. But for anything else, they'll be set to their default value. Their default value will be constructed. The default constructor will be called for that value, and that's the value you'll get. The basic types behave a little bit differently than everything else. Yeah. It will attempt to read from it, but it'll, like, if the person did like Bob 94, 95 or something, since Bob is not an integer and row wants to read an integer, we'll stop there and we won't have read anything. So the integer input is not going to skip things that happen to be in the stream until it finds numbers. It'll stop if at the first like non-number value it finds. Any other questions? Okay, so now we have one other thing that we need to check. We need to check to see if the move is valid, which is back over here in Tic Tac Toe. So we have a bool is valid. And it won't change ourselves. And we'll figure out if we need any other input in a minute. So what should our first check here be to see if this move is valid? What things have to be true? Has to be parsed correctly, right? So if not parsed successfully, return false, right? What else do I need?
They entered are correct.
We need, by correct, what do you mean correct?
Bounds.
So they need to be in bounds. For us to know in bounds, do we have enough information to determine that? No, right? What do we need to be able to figure out if we're in bounds? The board, right? So we might now have as a new argument to this function, we now might need to change this guy to include a const board reference board. And so what do I need to figure out? Well, I need to figure out if both the row and that column pair, right, are in bounds. So over here, we might now go back to move, and we might say, else if not board dot in bounds row column return false, right? And anything else that I need to check? Yeah. Right, and we also need to make sure that that spot is blank, right? Because you can't play on top of somebody else's spot, right? You can't put an X on top of an O or an X on top of another X. So this could probably be simplified down into just being a little bit more simpler, like returned, parsed successfully, and board dot in bounds row call, and board dot is blank space row call. And notice the order that I did these checks in is very important, right? If this one returns false, will I try to do this one? No, right? Because we had that short circuit evaluation. The first one that evaluates to be false is the one that we stop at, right? If this one fails, right, I'm not going to try to do this one. Which is really important because if I switch the order of these things, right, the thing might not be in bounds, which would probably cause some undefined behavior over here if I tried to go out of bounds on that board. Any questions here on this function? Are you guys catching like the drift that I keep breaking everything down into smaller and smaller problems? Right? Everything that I say is a step becomes what? Well, but like each of these steps that I have in here, right? There's 3 steps in there. What did each one more or less become?
One step.
A function, right? Anything that's kind of complicated becomes a function. So we now have some more functions we have to define over here on the board. So bool in bounds, int row, int call. Are we going to change ourselves? Nope. So const. So what does it mean for the row and the column to be in bounds? Well, I would say that the row has to be between 0 and the number, the size of the board minus 1, right? If you're doing like, or it has to be greater than or equal to 0, but less than the number of rows, and the column more or less has to follow that same convention. But we might say, return is between, well, is the row between 0 and, we call this its size. Do you want this function is between to be inclusive on the upper boundary or to be exclusive on the upper boundary? Inclusive. Inclusive on the upper boundary. It has to be between A and B, inclusive. Exclusive, it has to be, it's inclusive on A, but exclusive on B. I think more people wanted to be the first one, so -1 and is between row or call 0, its size -1. Right, so again, I came up with 2 new problems because we should keep breaking these things down. This function right now that I've just written, the is between, this function is going to probably end up being static function inside of board because I don't need any direct information from the board itself to operate on. So I'll make a static function over here. Static is between. That's what I called it. Then we have int val, int lower, int upper. That's cool. So this function's now a static method inside the class. And this function's pretty easy, right? We have to return what? Val has to be greater than or equal to lower, and val has to be less than or equal to upper. Fantastic. Yeah. It's static because notice I don't make any reference to any of the member variables or member methods of the board. Right? I don't need access to the board state or the blank character or anything else, right? And so, like, if you don't like this guy being mixed in here, because it does look kind of ugly being here right in the middle, we could have like another little private section for private members up here. And then the other thing that we said that we needed was is blank space. So bool is blank space, int row, int call, const. So what can this function do to check to see if this spot is a blank space? Well, board state dot at row dot at call has to be equal to the blank character. Fantastic. Any questions about what we've done so far? So we've done quite a bit of work, so probably now might be a decent time to commit, right? And so you, in the commit message, you kind of say what you did, right? So added some more methods, board, created a move. And now that's like another checkpoint, and we can go back to these if we need to later on. We're back here in Tic Tac Toe. So again, we still need to initially pass in who the player is. Over here, we need to pass in the board. But we seem to more or less be good with this function, except we now need to know who's making this move. Not a trick question. It should be, yeah, duh. Who's making this move? Which player? Player 1 or player 2? It's the current player. That's a trick question, not the second part, right? The current player is making the move, right? No one else is. So we need another method to be able to get current player, right? Because we need to pass in the current player to our function over here. So we pop back on over to Tic Tac Toe, and I'm going to make 2 versions of get current player, and they're both going to look identical, but the reasoning for having to make 2 different ones is because of the types returned. So we're going to return a const player reference get current player const, and we're also going to return a player reference get current player, not const. One allows us to modify the player, and one does not allow us to modify the player. First one, you can't change the player. Second one, you could change the player. And in general, when you're doing something like this, you're going to need both versions of it, because sometimes you'll need a const reference to the player. Other times you'll need a non-const reference to the player. But over here, fairly easy. Return, oops, players dot at player turn. And then popping back, this one's going to be identical. But because of the typing issues in C++, we're probably going to need both versions. A good question to ask is this one right here, we have get current player turn. Which version of this function do you think it's going to call? The const version or the non-const version? So who thinks it's going to call the const version? Who thinks it's going to call the non-const version? Who thinks the compiler will randomly pick one? Because it doesn't matter. No, it does matter, and it's going to call the const version. The way that you can know this is because we're const, right? So if we're const, we can't change ourselves, which means the only functions that we can call are other functions inside of ourselves that can't change ourselves, right? So this function over here promises not to change myself, so I can call this one. This function over here says, I might change you, right? I might change myself, so I can't call it here. Because it could theoretically modify me. Because it doesn't have this const over here at the end. So it has to call the const version over here. So great. We have now gotten a move. What do you want to do next? So, like, make the move? Sure. Right, which is this guy over here. So we need move.make. And what do we make our move on? A board. So we're probably going to need to pass in the board to make that happen. So over here, we're going to pass in the board. And back here in move, we now have another function, void move.make. And it takes in a board reference board. Oops, this is called make, my bad. And so, what do you think we should do here? Yeah. No, we've already know that it's valid, right? Because the only time we can call this function is after we've gotten a valid move. So the move has to be valid before we can even attempt to make it. So we're guaranteeing, at least the way our code is structured right now, the move is valid. Right, it has to be valid. So we don't need to do those checks there. Yeah. Yeah, we need to go make the board at our row column equal to whatever the user's character is, right? Yeah. No, it will not come to this function if the move is not valid, because if you look down here when we get a valid move, while the move isn't valid, what do? We try it again, right? We keep going until we get a valid move, and hopefully you guys are structuring your rock, paper, scissors game in a similar manner, where you keep asking for a valid move until they enter a good one. So we do need to do something like, board.set, and we're going to do something like, set the position at this row column to be equal to, sorry, the maker dot, well, our maker now probably needs some more methods, and player, because private, the player probably has a name, right? And they might also have a character called their piece. And here, because we're running out of time, a run or code, you can say generate, I want a getter and I want a getter for both of these things. So thanks, Sea Lion. It just wrote those functions for me. And then over here we need another function void set, and we have an int row int call char value. So set the board at this row and column to this value. Over here, right, this is just like board state dot at row dot at call equals val. And then back here in move, maker dot get piece. Fantastic, right? We wrote our function. In this, for this particular problem, updating the state of our game for Tic Tac Toe was very, very simple. Once you have a valid move, you just slap it on there. But for other games, it might be a lot more complicated to make that person's move, right? Think about like something like Monopoly, right? You roll somebody's dice, and like what can happen after you make that person's move can be very complicated, right? Because you might have to land on somebody's property and pay them, or you might land on like go to jail and have to send the person to jail, or pass go and have to give them money, or they land on an unbought property and you have to give them the option to purchase it. So that could be very, very complicated. We will wrap this up on Monday. Hopefully you're picking up some good programming tips. If you do have questions about what we're doing, ask, because I do know I'm going very quickly through all of this. And I'll also make sure to put another commit in here.
Professor, real quick, how do you take off